Hmm. This is David. Not that many people. I wonder if the mistake I made off by 12 hours and send out the agenda is the cause of this problem. Okay, let me go ahead and show the note well slide so we can say that that was done. Okay, so that takes care of the note well slide. So back to the agenda. Only see, including myself, 11 people online. That's a bit short of where we've been in the past. I suppose we can try to make some progress here, though. So Peng, I know you're working on a revision to the requirements draft. What's the expected timing on finalizing and posting that?
Because the updates are just proposed by some of the courses, but not all of them. So I'm just going to send to the main list. Before that, I want to know if there are any comments within the courses, but I haven't got any. So I'm just post them now. Yeah.
Okay, that sounds good. So perhaps we'll have discussion in the mailing list the next few days, and maybe end of this week, we'll see a revised version of the draft. Is that plausible?
Yes, but would you like to uh, that we just post a new version, or we just send updated version to the main list first?
I think a discussion of what you're planning to change on the mailing list first would be a good idea before you post the new version.
Okay, sure. I'm going, but my computer was really slow, so I didn't finish it.
Okay, I mean, I understand. I had
Yes,
a lot of
maybe
things I would
within
have.
5 or 10 minutes, I will send it out.
Okay, it'll be fine. I mean, I had a lot of stuff I was planning to get done last week, and others. Life is what happened while one is busy making other plans. Okay, thank you.
Oh, sure.
Um, okay, Shafu, you wanted to say something?
Yeah, for the gap of TSN mechanism and between the requirement document, I have a comment that can we submit a separate document to describe that? That is my comment.
When you say separate document, what are you thinking of?
Because there may be many description about the gap of the existing TSN mechanism and the requirement document. So I think it's not easy to add too many information in the requirement document to describe that.
Oh, okay. So
Uh,
I think I understand the question. I'm not sure. Um, it as it's sort of implied in the wait a minute, let me see if I can get all that blue background off. I'm sorry, I didn't mean to do that. Okay, as it's implied in the agenda, it'd be a good idea to evaluate the TSN queuing and scheduling mechanisms against the requirements draft. It'll give us some confidence that the requirements are that we understand the requirements and that the TSN mechanisms don't need them. Yes, that ought to be in some sort of separate document. If it's convenient to do it as a draft, that's fine. If it makes sense to do it on a wiki, I wouldn't have a problem with that. But I think I'm agreeing with you. The TSN evaluation should not go in the requirements draft. I think Peng has his hands full already.
Yes. So so in the week the test run with the TSN queuing scheduling mechanism is just to test, or it is necessary to submit a document to describe why the TSN queuing scheduling mechanism does not satisfy the requirement document. So I suggest the later a separate document may be necessary.
If you're willing to work on that document, that would be fine.
Okay, thank you.
All right. Let me see if I can get some stuff going in the notes here. There we go.
Hi, David. I have one more comment for this proposal.
Okay.
I think I remember there is a published RFC in DETNET working group. It is called bounded latency. And in this document, there is a summary of the existing TSN queuing mechanism. And the motivation of this document is just to show that the existing TSN mechanisms can satisfy the requirement of DETNET. So I think the conclusion that the existing TSN mechanisms cannot satisfy DETNET requirement is a little I don't know how to say it, because the requirement, for example, of scaling raised by DETNET is also case by case. For example, sometimes in a layer 3 network, it is quite big and a lot of flows, and we need some scalability. But it doesn't mean, I think it doesn't mean that all the existing TSN mechanisms can satisfy the requirement of DETNET. It's just some of them cannot satisfy some of the requirement. So maybe I think it can make it case by case rather than have a separated document, because that will make people think that all the TSN mechanisms cannot be used. That is my concern.
Hang on, I'm taking notes.
Yeah.
Give me a minute, and then I will I will try to remember what you said and respond to it. There's only one of me.
Yeah, take your time.
Would help if I could spell Xiaofu's name and not mistype it. Okay, so I think, Shusong, if I understood your question, it was, are we expecting that every TSN mechanism will meet none of the scaling requirements, or are we expecting that some of the TSN mechanisms will meet some of the requirements, but none of them will meet all of the requirements across the board? Is that the question
Yes.
you thought you were asking?
Yes, I think not only the existing TSN mechanisms. Actually, I think all the mechanisms that we have raised cannot satisfy all the requirements at the same time. So I think we cannot give an impression to other people in IETF or in IEEE that we have a conclusion that TSN mechanisms cannot satisfy these requirements. It depends, I think, case by case.
Okay, so I'm quickly writing down my answer here, and then I'll read it. I think I agree with you that it's unlikely that any existing TSN mechanism or a new mechanism will meet all of the scaling requirements. Individual mechanisms will meet individual requirements.
Yes. For example, I think today we will have a discussion about the TCQF and CSQF. These two mechanisms is the some extension or some enhancement based on the existing TSN mechanisms, CQF. So the basic idea here is that CQF has some scalability problem. So we have some modification based on that existing mechanism. So that will be very clear which mechanisms has what kind of scalability problem, which cannot satisfy the requirement of DETNET, and what kind of more we can do in DETNET to make it work. So I think it can be done case by case rather than to say that all the mechanisms in TSA cannot be used.
Okay, so I will need to read you everything I'm scribbling down here, as I hope I'm not putting words in your mouth.
海大卫的学生, just a quick response to this discussion. Yes, I agree with学生 that it would be case by case, but my motivation is that there is a good place for a separate document to describe that case by case. For the TCQF or the CSQF, that is bring the enhancement to the traditional TSN CQF. I think it is a very good job. So my comment to the separate document is mainly to describe the classical TSN CQF and other mechanisms. We welcome any enhancement to this existing mechanism. Thank you.
Okay, I should go read back what I'm busy writing down because I seem to be taking the notes. So Shusong, what I first wrote is Shusong and David agree that it is unlikely any TSN mechanism or new mechanism will meet all the scaling requirements. Individual mechanisms will meet individual requirements, and it may be necessary to select multiple mechanisms to provide mechanisms that can meet each of the scaling requirements. Results will be case by case with individual mechanism selection based on what's important for specific usage scenarios.
Yes, that's exactly what I mean.
Okay, I didn't miss that. And then Xiaofu, what I think I heard you say was a separate document to capture classic TSN mechanism state with respect to scaling requirements would be a good idea. Is that correct?
Yes.
Okay.
Yes.
All right. Shusong, I cut you off briefly. You should go ahead and respond, and then I think Iju is next.
So I'm thinking it's probably a good idea that each of the solution documents try to capture its own evaluation section. For example, for TCQF, it is quite clear that it tried to extend the CQF in order to meet some of the scaling requirements. And for the, I think for the what's that called? Sorry, that's draft asynchronous framework. I kind of think it should, it probably can try to evaluate the TSN ATS because that's the most relevant and stable reference it can use. And for shuffles, I might be wrong, but I kind of think it's also the ATS, the asynchronous traffic scheduling, is a good source that you may try to start with for the evaluation for each of the requirements. So in summary, I kind of think we probably can leave it for each of the solution document to try to capture its own uh, to explain why uh, such new mechanisms or mechanism extensions can meet the scaling requirements rather than using a standalone separate document to capture everything.
Oh, I think you might accidentally be agreeing with Xiaofu's. I think what I heard Xiaofu say was that if we're going to evaluate the existing TSN mechanisms, that ought to be a standalone doc. I think I agree with you that the authors and proponents of each of the new mechanisms are in the best shape to evaluate how they think their new mechanism meets the requirements. My underlying and my underlying concern, which is why am I wasting time on this, is I think the first mechanism or two that goes through this evaluation against the requirements doc is going to have a harder time than the subsequent ones. And so I'd like to take something well-known and existing that hopefully doesn't bias us one way or another among the proposed mechanisms to use that to survive that. Does that make sense?
Yeah. So yeah. So if I understand correctly, are you saying that if for each of the document authors, if the authors would like to try to post or contribute to that Liu Peng's requirement document, we can directly put it into current working group requirement document. Is that what I heard, or I misunderstood this part?
No, let's
Uh-huh.
see. Let's see. I think I agree with you on who does the work. I'm not sure I want
Okay.
to pile everything into the requirements doc, because at the end of the day, the requirements
Okay.
doc is going to have to stand alone as requirements doc.
Yeah. Okay. I see. Yeah. Then we are in line.
Now I got to capture what we just talked about.
Yeah, one more thing is the so-called classic TSN mechanism, because the TSN actually not just a single mechanism; it's a toolbox. So
It's classic.
it is yeah, it is fair that for each of the solution proponent to to do this work is more fair. Yeah.
All right, let me go. Okay, I think I've got that captured in the notes. And Iju, were you also suggesting that perhaps some of the solution authors might want to take on evaluation of the TSN mechanism that's closest to their solution?
if each of the solution document draft can have such a section at least, so that so the readers can clearly know that this particular solution, why and how this particular solution address the scaling problem.
Okay, agree with that. And are you also suggesting that the solution doc, that a doc for a new solution ought to also evaluate an underlying TSN mechanism if it's based on an underlying TSN mechanism?
Yeah, to have a section to at least to explain it. If not the evaluation, I don't know whether the evaluation means have to provide the data, testing data, or something like that. But at least I think it's worthwhile to add some explanation. And it would be good if because we have this interim meeting, some of the authors, I think, probably want to show the testing data in the slides rather than in the documents, because it looks not so common that the testing data appears in a draft, right? So I mean, either the explanation or the testing data.
Maybe every every solutions can evaluate themselves and give one more slides. Just like I remember in Shop's slides, there was evaluation or a result. So after that, we can put them together to discuss more about the performance, I think.
I kind of think it depends on how we define this evaluation. It could be just explanation, like a table, check against each of the requirements in the working group document to say I meet this, or halfway meet this, or not cannot meet this. So this is a form, one of the forms for the evaluation. Another evaluation is to show some testing data. So there are two forms, at least two forms of evaluation, I think. So
Yeah, I might try to split those. Certainly, if I go back to some of what we discussed in earlier meetings, something closer to your second alternative, I think, is more important. So a quick summary of the extent to which a mechanism or solution does or does not meet the individual requirements. Testing data is always interesting and useful, but I tend to think testing data is more relevant as demonstration that the solution actually works.
I think testing data could be presented during the interim meeting in the slides, but for each of the solution documents, it would be we suggested that there a separate section try to do the something like the table evaluation for each of the listed requirements. That's so-called we so-called evaluation, right? In the draft, I mean.
Yeah, and we may have to come up with better terms for what we're talking about here, because we're using evaluation to mean two different things right now. I don't think that's helping anybody. And I plead guilty to being part of that problem. Okay, I think I've got that captured. So Xiaofu, were you proposing to actually start the document to capture the state of the classic TSN mechanisms with respect to scaling requirements?
I think it is still necessary to do this work because it is common to all new mechanisms. So I think it may be redundant for each new mechanism to add a section to describe that.
I sort of have two opinions on that. On the one hand, I think a standalone document describing the existing mechanisms makes a lot of sense. On the other hand, I think I'm sympathetic to Iju's view that for a new mechanism, documenting how it does or doesn't meet the scaling requirements might be best done by the proponents of that mechanism, the draft for that mechanism.
Yeah, for the new mechanism document, it is necessary to add a section to describe the checklist based on the requirement document. Yeah, I agree with that. But for the existing classical TSN mechanism, because it is a common problem. I'm not sure it is good for each new document to describe that repeatedly. That is what I worry about.
Shaofu, I'm actually a little confused about the common thing you have mentioned, because I think as Li Zhou has already proposed, maybe when we when we discuss one mechanisms in DETNET, maybe that kind of mechanisms that has already been discussed in TSN, and what we have done is just to propose some modification or enhancement based on the existing mechanisms. And to that point, in that document, we can analyze what kind of scaling problem for that type of TSN mechanisms, because there are a lot of mechanisms in TSN. So I'm a little confused. You have mentioned that there are some common problem in TSN mechanisms. What do you mean?
Misunderstanding some description. I regard that for each new document, it may be unnecessary to add a section to describe the existing classical TSN mechanism. Sorry, to describe the gap of the existing TSN mechanism between and the requirement document. So if you think it already we got a consensus that the existing TSN mechanism does not satisfy the requirement document. I'm not resist that I'm not insist that we must have a separate document.
And as I said earlier, I would like to see at least one of the classic TSN mechanisms taken through evaluation against the scaling requirements draft, so that we can learn from that experience about how well that works, and maybe we'll have some more stuff for paying to revise the scaling requirements draft again.
What you have suggested is to take one TSN mechanisms as an example to analyze why it cannot satisfy the existing scaling requirement. Is that your proposal?
Yes.
Yeah, understood. Actually, I think maybe TCQF and the CSQF can give a proper example for that, because it is the very clear enhancement to the existing CQF problem, and the CQF problem for scaling is it is not suitable for long distance, especially the link delay is very big. Maybe we can go into it when we discuss these two mechanisms.
Okay, so I think you said is that much of the evaluation of CQF against the requirements draft may already have been done by the folks who are working on both TCQF and CSQF. Is that correct?
I think so.
Okay.
There's points
So
that the CQF requires a time synchronization, and our requirement, first of the requirement is to require not really for time synchronization, maybe
Oh,
frequency synchronization.
ping,
Yes,
ping that's expected.
yeah,
Okay.
okay, sure.
uh,
So for other, sorry, for others, maybe unsynchronization-based solution like Shaofu solution and Genos, maybe they can give more analysis if there is, I think.
um, I think for the TCQF part, or CSCQF anyway. So the original draft, which is my draft is EJO CQF variant. It takes quite a long chapters or sections to explain why the traditional CQF cannot meet the scaling requirement, and explain in quite details, but it is not in the form to check against one by one of the requirement listed in current working group document. So I think if there is you think that it would be worthwhile that we have a separate we have a at least example document to show that one of the existing TSM mechanisms, which is CQF, should be taken through the evaluation against one by one requirement in the in the working group document. I think I can modify that draft to make it more clearly stated in this form, at least.
That might be good. If you could put that together and put it in the wiki or send it to the mailing list, that would be helpful.
Yeah, thanks.
Okay. Okay. And all right, that would be that would be a good start. All right. Any other comments or questions? Okay, Shusong, did you have slides on the SR-based bounded latency draft?
I have prepared some slides. So the TCQF will be presented next time.
I think that's the plan. I think the TCQF authors the two drafts could use a little bit more time to come to a common view of things. And I guess we can start here. I mean, one of my questions is whether we have a common underlying extended CQF scheduling and queuing mechanism, and we're looking at 3 ways of doing the communication instances, and whether there is something fundamental about SR that makes what you're proposing this draft different.
Yeah, okay. I will give some introduction to that. So I can share my
All
screen.
right, let me go stop sharing so you can start sharing.
Okay. The assumption here is that people has already be familiar with the CQF mechanisms and also the TCQF, and the CSQF is kind of based on this presentation. It seems like I have already gave a request to share my screen.
Oh, I'm sorry. Wait a minute. There it is. I need to go say, yes, you can do that.
Yes.
I'm sorry.
It's okay. It's okay.
Too busy taking notes.
Yeah, thank you. It's taking notes is really difficult, at least for me. Can you see my screen?
Yes.
Yeah, okay. I will give
Okay,
some.
and would you please send me these slides afterwards so I can get them posted into the meeting materials? After
Sure.
one of these meetings, I get an urgent request of, can I see the slides? I'd like to do that promptly this time.
Sure. I will send it to you. What I'm trying to introduce today is cycle-specified queuing and forwarding mechanisms. We call it CSQF. And this slide is something I have presented in this IETF. There are 3 parts of mechanisms for guarantee bounding latency. The first one is queuing mechanisms, which is the core of our discussion. Another one is encapsulation, because this mechanism is based on SR. So I also mentioned this part, and also resource allocation. In these mechanisms, CSQF based on the controller or centralized path and resource calculation. And first, I will give some brief introduction of the queuing or shaping mechanisms. Basically, we have 3 or more than 3 queues, and there are different rules for these 3 queues. One of them is the existing output queue, and one of them is the target input queue, and another one is the burst tolerant queue. If we have more than 3 queues, we have more than 1 burst tolerant queue. So we can tolerate more burst, and each queue will correspond to a cycle number. The cycle number means that in which time slot the queue will be the output queue, and the target cycle number will be updated based on the existing timeline. For example, this following pictures shows what will happen in each time slot. For example, in cycle 1, if we have received a packet which is have a label to indicate it to be sent out in cycle 2, it will be put in the
Chusong?
Yeah.
I'm still looking at your title slide.
Final slide?
No, what slide are you on? My screen is showing your title slide number 1.
Oh, sorry. It's so what about
There we
now?
go. Now you're on 3.
Sorry.
Now I see it.
Okay. So I will quit the presenting mode. Maybe you cannot see the I switched the slide. Yeah, here we
Yes,
go.
that will work better.
Yeah.
Sorry about that. I think MeetEcho and PowerPoint didn't get along.
Okay, understood. This is the previous slide that this has already been presented in IETF 6. And now we're going into the queuing mechanisms, and we have 3 queues. Each queue have a different role, and each queue have a correspond cycle number. And for take it as an example, when we are in the time slot of cycle 1, we have a packet of cycle 2, which means that the packet is supposed to be sent out in cycle 2. We will put it into the Q3 because that is the target input queue, and the target cycle number of Q3 is cycle 2. And if we have received a packet that is labeled as cycle 3, we will put it in Q1 because it is the burst tolerant queue. And if in cycle 1 we have received a packet which is has a label of cycle 4, we have no queue to put it because we have only one burst tolerant queue in this example. But if we have more queues for burst tolerant, we can also put the cycle 4 packet into the queue. And that is what happening in cycle 1. And if we have if the time slot has passed to cycle 2, the cycle number for each queue will also change, and the role of the queue will update it. That is the mechanisms. That is quite similar to CQF. What has been changed is that we add more queues for burst tolerant. And so the question is that how to provide bounded jitter in each hop. The basic idea is here we have 3 parts of latency. One is for processing, one is for queuing, and one is for output port. And the link delay is stable, so it is not discussed in this slide. The link delay won't cause jitter. And the processing delay will have some jitter, and the queuing delay is bounded by the mechanisms itself because the time slot has already been scheduled. So the jitter will comes from the processing delay. And when the processing delay is small, we will give it a larger queuing delay to make it a bounded jitter. And if the processing delay is large, the queuing delay will be smaller. So the case is that because there is jitter in processing, so in the queuing we have the corresponding mechanisms to tolerate that jitter. So what is happening is that after all these mechanisms, each hop, the latency can be expected and the jitter is bounded. That is the queuing part. And so how we guarantee that in each time slot the packet can be sent out and there is no confliction, no congestion. The answer is that the controller knows that, because the controller knows the traffic specification of each flow, so it will reserve the time slot for each flow, and it will calculate the path and at the same time calculate the time slot for each packet, and to indicate that which time slot the packet is supposed to be sent out in each hop. For example, in this picture, the calculation result is that the packet will be sent out in cycle 1 in node A and will be received in cycle 2 for node B and sent out in cycle 3 in node B, and received in cycle 4 for node C and sent out in cycle 5 for node C. So that will be the calculation result of the controller. And then that is the reason why we need the SR label, because there will be a label stack for the path to indicate which output port the packet should be sent out. And if we enhance that part, we can the SR label or SRv6 seed not only indicates that which port the packet should be sent out, it also indicates that which time slot or which cycle the packet should be sent out, which is also the result of the calculation from the controller. So in the first function, we read the seed and we know the output port for that packet, and we also read the seed and know the cycle number the packet should be sent out. And based on the cycle number, we know which queue we should put the packet into. And when that queue will be the output queue, the packet will be sent out in the indicated time slot. So that is the whole idea. And we give, I have given an example. It's very simple to show how it works together. First, we have to give the controller some information about the topology, about the meaning of the label, and also some basic delay information. For example, the link delay, the processing delay. Maybe the processing delay has some jitter, so it will be a rank. For example, 10 millisecond to 20 millisecond, and also the proposed queuing delay. And after the controller has already collected all this information, it can calculate the path. The path will satisfy the requirement of the end-to-end latency and also the end-to-end jitter. After the path calculation, the controller will also indicate that in each hop which time slot the packet should be sent out. So it will present the result as a label stack, and label stack will be allocated to the first hop of the path. And then the packet will forward it based on the label stack. The label, as I have mentioned, not only indicate that which output port the packet should be sent out, also which time slot the packet should be sent out. So it just will send the packet based on the label, and the underlying mechanisms is the queuing, the cyclic queuing mechanisms, as I've mentioned. And because for each packet, the arriving time is different, so there will be different label stack for different packet in the same flow, but there will be a pattern because the traffic specification of the flow is known by the controller. So there will be a set of label stack allocated to the first hop of the path, and when a packet arrives, it will select the right one to indicate that packet to go through all the paths. And if there are different flows, the intermediate nodes will not recognize which flow the packet belongs. So it just recognizes the label. So so there will be no flow status maintained in the intermediate nodes. The nodes just send out a packet based on label, and that make it more scalable when there are multiple flows running in the same time in the network. And the controller will deal with the possible packet confliction because there is resource reservation beforehand. Even these two flows share the same time slot, the controller will guarantee that this time slot is enough for both flows to be sent out. And because we can see these mechanisms depends heavily on the controller mechanism. So we have done some work about the how to do the calculation, both the path calculation and also the time slot calculation. And there's offline planning, there's online planning, and there are different goals. I won't go to details because this is related to the controller algorithms. It's just give some idea that we have already done this and it can work. And there are different kind of algorithms. For example, the Coulomb generation or Grady. And here is some scenarios we have used as an example for path calculation, and it is give some idea how many nodes can be calculated, how many flows can be carried in this network. And here are some results. And also we have done some work about load balance. It means that because the controller knows everything, it can give some mechanisms for load balance to make the network can carry more flows. So here are some basic questions from David, perhaps also from the working group. So we have 3 documents what about the queuing mechanisms? Are they share the same or common queuing mechanisms? Yes, the underlying mechanism is the same because it's all based on the cyclic queuing mechanisms, and there will be a time slot for each output queue, and the other queue is for jitter tolerant. So what is the difference between, for example, TCQF and CSQF? Actually, the basic idea is that the mapping relationship is calculated by the controller. Here is the picture shows how the controller calculates the mapping relationship between each nodes and each time slot. So the controller will calculate it. For TCQF, the mapping relationship will be maintained in each node, and it is stable. But for controller, it is calculated together based on the collected information, and so the controller can also adjust the mapping relationship based on the reservation status. For example, if based on the previous mapping relationship, the time slot is full and cannot carry on another packet in that time slot, there can be some adjustment. For example, if we have more queues, we can put the packet into another time slot, and it can also be indicated by the label stack. So it is kind of more stable in scheduling because it is based on a centralized controller. Yeah, that is my presentation. Maybe do you have any questions about these mechanisms? I can give more explanation.
Your label stack diagrams look like you're passing 2 entities in each label, one of which looked like a cycle number. Was there a second entity?
Not really. Actually, we have give the label 2 meanings. For example, in the previous mechanisms, for example, traditional SR, each seed will represent one output port, for example. But now we allocate a set of seed for one output port. It means that, for example, 100 from 1001 to 105, all these 3 labels represent port 1. But the difference of these 5 labels is that it present different cycles. So it means that if we have 103, first we know that the packet will be sent out in one of the output port.
Could you go forward? Could you go forward a few slides? What I didn't understand is I saw some. Keep going forward a few slides. I saw some slides where it had things like 1-210. No, I'm sorry. The other way. 2 later slides.
Later.
Okay. Yeah, right there. What does at the top right? What does 1-210 and 2-160 mean?
It's just actually it's just an example. There is no meaning for a dash here. It's just the same as the 101 or 102.
Oh, okay.
Yeah.
Okay, so you're only sending the cycle count, and the rest information is a port selector.
Yes, yes. Because this example is we take SRMPS as an example, so the cycle ID will be represented by a label. But if we use SRV6 seed, for example, we can define the cycle ID in the arguments of SRV6 seed. It's similar, so I just take MPS label as an example.
Thank you. Making a note of the answer to my question.
Yeah.
Okay,
So,
thanks. That was slightly confusing. Okay, let's see, where am I? Click there. Xiaofu, go ahead. Xiaofu, if you're speaking, the audio is not coming through. Xiaofu may be having audio problems. Can other people hear me?
yes, David, I can hear you well.
Okay, Xiaofu says he's having a problem with being unable to unmute.
Oh,
When he gets his mic fixed, we'll try again. Yishu, go ahead.
Thanks, David. So, Xuesong, I know this is for the SRv6, right? Basically for the SRv6 encapsulation, and you try to use the SID, which is a concept in segment routing. I'm not the expert in segment routing, so would you please illustrate a little bit more regarding, for example, in segment routing, there are different types of SID, right? So, is there any um, extensions or constraints because of the encapsulation and because of the segment routing encapsulation we need to follow? Is there anything?
yes. Actually, we introduce new meaning for the existing seed. For example, for MPS label, the previous label is only to indicate, for example, other adjacency seed or no seed, just used for routine. But now we use it for time information. There are two modification here. One is that we introduce new meaning for the seed, and it also indicates the new functionality. And another one is that we need more seeds. For example, we need more MPS labels for each output port because we have to indicate for each output port the difference of different cycles. So that is the two new things we bring to the traditional SR MPS or SRv6 mechanisms.
Xiaofu, go
Hello?
ahead if your audio is working this time.
Okay, Sangha, I'm sorry about it. My concern is that is still that how to guarantee there is no conflict on the transit node if the node received multiple flows from multiple sources.
Oh, that is really a good question because that is the sweet part of these mechanisms. This slide shows that how we do that. For example, we have a flow from the destination source, and we have give it a path from A to B to C and to the destination. And because the controller has already collected the link and the processing delay of each node, so it will give a time slot result for each node. As I have mentioned in this, the the result is that cycle 1 for A, cycle 3 for B, and cycle 5 for C. And this is the result for this flow, right? And now the controller knows that in cycle 1, there has already been a packet. And for B, the cycle 3 has already been a packet. And the blue one is the newly scheduled flow. And you can also notice there is gray one. That means that is the flow that has already been scheduled in that time slot. Because the controller knows everything. Even the path is different, the source is different, there are multiple flows, but the controller knows that. So every time the controller schedule a new flow into this network, it will check whether the time slot in, for example, cycle 1 for node A is full or not. For example, for the capability of node A, the cycle 1 can only provide resource for example, 5 packets, and of course there will be a maximum packet size. And if we have another flow that make it the 6th packet in that time slot, the controller has to reschedule because the node A cannot give the resource for that flow in cycle 1. So that is the most important thing for these mechanisms. And that is also what we are trying to do in all these controller algorithms, because the controller has to check whether the time slot is used or not, and the time slot is enough or not. And then it can give the result of the calculation. And when the controller can give the result, it means that, okay, the resource is still enough and there will be no confliction. If the controller cannot give the result, it means that, oh, we have already all the suitable time slot has already been occupied. There will no more resource for a more flow. So that will be the maybe a rejection to the new request from that flow. So each flow that controller can provide the result, it means that the resource is reserved.
Okay. I I have little confused about the can you go to the previous picture?
Sure. You mean slide 5?
Yeah. Okay.
Yeah.
So if we take a look at this figure for the transit node C,
Yeah.
there may be multiple flows received from different incoming port.
Yes.
Then, for example, the flow 1 and the flow 2, there may be from multiple sources. So
Yeah.
I'm not sure how the controller to calculate, for example, it knows that flow 1, we arrived at the transit node C, for example, it may consume the cycle 3 in transit node C. And
Oh,
again, the flow 2 may still consume the cycle 3. That is the same cycle on the transit node C. But these two flows may there is a large time interval between these two flows, but they just take the same cycle 3. So
yes.
it is actually not conflict at transit node C because there is a large time interval between these two flows. So I'm not sure how controller to distinguish it is the the there is an actually conflict or there is not actually a conflict. That is my
Oh,
concern.
actually, the point is that because we have a time slot length. For example, how long the cycle will be. For example, it's is 10 millisecond, and then that is scheduled beforehand, right? And then we know the capability of the output port for node 3. For example, it's 10G, and then we know in each time slot how many packets the for output port for node C it can send it out. It's a number that we can calculate it, or the controller can calculate it. So when a new flow arrives, it says, okay, there will be a packet in cycle 5, and then the controller will check how many packets that have already been scheduled in cycle 5, and whether there will be more space for cycle 5. And then the packet size matters, and what we use is the maximum packet size, because the parameters of that flow include some core information for the calculation. One is the maximum packet size. Another one is the pattern of the traffic. For example, the interval of the packet and the maximum burst of each interval. For example, you can see the gray packet in node A. It means that in each cycle there has already been a flow. There will be a packet in each cycle. So that is the pattern for that flow. And for node B, there is another flow that, okay, there will be 2 packets in each cycle. So for based on that pattern, the controller knows that each packet will supposed to be sent out in which cycle, and also based on that, it can decide whether that cycle's resource is still enough or not.
I'm sorry. I think that there is a assumption that for each cycle there is gray traffic on each cycle, but I think that may be not the case.
No, it's just an example. It can the pattern of the traffic can be different. It's just for this
Okay.
example, it's for
Okay.
each cycle there will be two packets, and they can different. For example, there are 10 cycles and 1 packet. It can also be calculated by the controller.
Yes.
But remember,
So if
mhm.
sorry, go ahead.
But remember, if the cycle number of the packet for the packet to arrive is not determined, it means that there will be jitter for that traffic. So we have to maintain more queues for that jitter. That is the rule, because if you want to tolerate more jitters, you have to maintain more queues in the device. So, but if which cycle the packet will be arrived is determined, there's no jitter, so there won't be more queues for uh, tolerance that jitter.
Thank you. But my question is not that. My question is that for example, the gray traffic and the blue traffic. Uh,
Mm-hmm.
for the transit node C, how the node C to determine there is an exactly conflict between the gray traffic and the blue traffic, and that is not an exactly conflict between them. For example, the gray traffic may arrived at the transit node C 1 hour ago, and 1 hour
Oh,
later the blue traffic arrived at transit node C.
it's
Even
1 hour is a too long jitter, because for DETNET there is some assumptions here, because if we want to do the time scheduling, the arrival time of
the
the packet has to that can be expected if
no the
you reserve
question.
the flow. You have to pay
Sorry.
attention to that. If you reserve a flow to the controller, and you mention that, okay, our packet will be arrived 1 hour later, it means that the timeline of reservation will be 1 hour later. So there will be no resource reservation for the flow in this hour, but it will happen 1 hour ago. But if you talk to the controller and says that, okay, I have one packet, but I don't know when it will arrive. So there is no deterministic for that flow, because you don't even know when it will arrive. There's no resource reservation. Or you can give redundant resource reservation, even though your flow hasn't arrived, but I do the reservation first, and whenever you arrive, you can get your seat. But you cannot say, okay, I don't know when I arrive, uh, uh, but when I arrive, you have the resource reservation ready. It's not reasonable. You cannot satisfy this requirement in any way.
Thank you. But uh, maybe we can discuss in minutes. The question is really not related with the jitter tolerance. It is exactly that, for example, source 1 send the traffic 1 hour later, 1 hour before, and source 2 send the traffic 1 hour later.
Yes,
Does
I think I understand your point. My answer is that if you arrive 1 hour later, it means that your reservation begins 1 hour later. But the assumption here is that you know exactly the packet will arrive 1 hour later. But if you don't know, you just don't know when the packet will arrive, the most I think the most efficient way is to do the reservation beforehand. It means that whenever you arrive, your reservation is already there.
I can send this question in minutes. Sorry, I wasted too many time.
It's actually you have to understand the assumption of DETNET, because for DETNET there is a traffic specification. What traffic specification means that it's the description of the traffic model of the flow. And if you have already provided your traffic specification, and for the resource reservation will be based on the traffic specification you have provided to the controller. So if you don't send your packet based on the traffic specification, for example, you have reserved a 1G bandwidth for your for your flow, but you only send one packet, it's your problem. It's not a problem of the DETNET. That is the case. For example, that is the case for every mechanisms if you do the resource reservation. You have to based on the resource you have reserved, or you can get nothing.
Yeah, what we discussed is based on the existing T-spec parameters.
Mm-hmm.
So I will send this question in minutes. Thank you.
Yeah, sure.
Okay, so I have a question for you, Shusong. I want to
Mm-hmm.
check whether I understand it. You said that the queuing and scheduling mechanism is the same, although is it correct that the centralized controller algorithm that you're using requires a label stack because the cycle number may differ at different nodes along the path?
David, I don't think I get your question correctly. You mean that the synchronization of the label and the queue, the corresponding relationship between the label and the
No,
queue?
no. What I'm
Mhm.
asking about is it looks like you've taken advantage of the SR label stack
Mhm.
so that the same packet can have a different cycle number at different nodes. Is that correct?
Yes, yes.
Okay, that's what I was asking about, because some of the other mechanisms I think I've seen would not allow the cycle number to vary between nodes, and that might be an important difference.
Yes, because that is also the benefit of these mechanisms. Because as this example shows that in packet for this packet, the schedule result is cycle 1 for A, cycle 3 for B, and cycle 5 for C, and each cycle can be represented by the different SR labels. And if we reschedule the flow, for example, to move the cycle 5 to cycle 6 in node C, we can just update the label stack, and the time slot can adjust based on the status. That is the flexibility from the controller. That is also the difference.
Okay, thank you. Tron?
Step two, you mean the controller path calculation and the allocation. So is the path planning is that exactly the path calculation, and the time planning is exactly the resource allocation.
Sorry, Quan, we missed the first part of your question. Can you repeat it?
I mean, what's the difference between the path planning and the time planning, path planning, time planning, and the path calculation and the resource allocation?
Oh, actually,
For
it
example,
happens.
the path planning and path calculation. Yeah.
Yeah, I think I understand your question. Actually, it happens together in these mechanisms because it's all done by the algorithm from the controller. For example, the traditional path calculation for the controller is that maybe we have to pick up a path that can, for example, satisfy the end-to-end requirement of a flow. But now the limitation is more. We not only have to satisfy the end-to-end latency, we have also to find a proper time slot in each node for that flow. So if the controller can give the result uh, of that flow, it means that okay, we have already selected a path that can satisfy your uh, latency requirement, and we also have already scheduled a proper time slot along the path. And if that result comes out, that means the resource reservation has already been done, because that time slot that has already been reserved for that flow. If next flow goes through the same node in the same time slot, the controller will decide whether the resource is enough or not. That is
Yeah.
also
Thank you.
what
So I think.
that is the result of this algorithm. There is a paper link I have already sent out in the mailing list. You can also get more details from that paper. This.
Yeah.
Yeah, you see it.
So I didn't see your.
Hmm? Sorry.
I didn't see your link.
Oh, it's in the mailing list. I have sent out email. I
Okay.
mentioned that more additional information. The last one is the link for the paper. It's this one. It's joint routing and scheduling for large-scale deterministic IP networks. Because you can even see from the title, it's joint routing and scheduling. It means that it schedules the time slot at the same times with selecting the path.
Okay, thank you. So, what I mean that if we should add a path planning or time planning is a new item for the control plane. So, maybe we could discuss more in the mailing list. It is related to the controller plane draft.
Actually, the controller, I think that is a good point. We can add some description in the path calculation because the existing controller plan framework document is just give some very initial description. It means that we have do the resource reservation, uh, we have to plan a proper path for a flow, but there is no description about the time scheduling. Maybe we can add something to that.
Yeah. Okay. Thank you.
Okay, Tianchi?
Yes, checking. Can you hear me? Just one.
Yes, we can.
Sure.
Very,
Hi.
very loud and clear.
Okay, sure. Thank you. Hey, Xu I have a question. Actually, it's regarding the Pahal behavior. Here, seems to me you're trying to give a Pahal behavior to all the devices along the path. Has that one been solved already? You know why I'm asking this question. So.
Yumi, has it already been
Pahal,
deployed?
yeah. No, it's like a Pahal behavior, like a per node behavior. Since suppose you have in one example, I forget which one you have been using. You have 3 nodes on a path. So for the controller side, the controller will be able to determine like the bounded delay or something for each node. So has that been not standardized? Because I'm asking because I'm facing the problem right now. So
yeah, it's actually not yet because the core part of the standardization is the extension to the SR MPS or SRv6. We have presented this work in Spring Working Group several times, but the conclusion is that it has to be confirmed by DETNET Working Group first. It means that DETNET Working Group has to say, okay, it works. It is requested by DETNET, and then the Spring can take it into their scope that okay, the SR extension is reasonable or not. So we are still now we are in the core point for this work. The DETNET Working Group people will say, okay, it works, and then we will standardize the SR part.
Oh, okay. So another thing
And
is actually,
this is,
sorry about that.
I just want to quick interject. This is David. I've been trying to support this sort of distinction between the queuing and scheduling mechanism and the protocol extensions needed to carry information for that mechanism. We could easily, it'd be nice if we're in a world where we had queuing and scheduling mechanisms that were amenable to different protocols for carrying the information that they need.
Yes, I think so. So, actually, as you have mentioned, David, there will be multiple ways for carrying this information. But for segment routing, maybe it has some benefit for these mechanisms. As I have mentioned, it can flexible indicate the time slots for each node. So there will be some coupling here, but maybe it will have some benefits.
Hey, Shizong, I have a follow-up question. What I want to know is like when you mention the traffic specification for a DNet flow, is that one for the end-to-end spec, or is that one also is a per node spec?
It's end-to-end spec. It's the description of the flow. It's the
Yeah.
how the
Okay.
flow arrives inside
Yeah.
the
So in
network.
that case, suppose in this example, you have ABC three nodes. How
Yeah.
are you going to split, like let's use the delay among the three nodes from the end-to-end traffic spec?
There is no actually. It's because in this picture you can only see one packet. The blue packet is only one. It's just leave node A to node B and then to node C. It's kind of a timeline. But for the traffic specification, it's the description of the behavior of one flow. It means that there will be multiple packets for that flow along this timeline. So the traffic pattern for that flow won't change. It's just what we have done is to transit each packet in that flow from one node to another. But from the view of the flow, the pattern hasn't been changed.
Okay. Okay. Yeah. So basically, if my understanding correct, you have
Mhm.
one queue for the jitter compensation.
Yeah,
So yeah, suppose that one is happening on the node B, right? So how much are you going to compensate at node B if your traffic spec is for end-to-end flow?
yeah. Actually, as I have explained in this page, the jitter bound is guaranteed by each hop. It means that if the traffic pattern is as described in node A, the node A will make sure that traffic pattern won't change because the expected jitter will be controlled in each node, and it means that the traffic pattern will be the same in node A, node B, and node C. It won't change because if there is any change brought by node A, for example, in the processing,
Mhm.
it will be tolerated by the tolerant queue, and it's like there is flexible for each hop, and the pattern won't change.
Okay, so since you have a coordinated management among all the three nodes in this example,
Not really. It's just
not really? Okay,
it's yeah, because it has already been scheduled by the controller. It's like it is supposed to be sent out in cycle one, but it processes so fast. It arrives early, and now we have a jitter tolerant queue. We can just put it in that queue. It can wait a little longer than before because it process fast. But
okay, got
if
it.
the
Yeah,
process,
yeah.
yeah,
Now I
if the
got it.
process
Yeah, yeah.
is,
Okay,
yeah, so that the basic idea is that it will be sent out in cycle one,
okay,
whatever happens. Yeah,
okay.
that queuing mechanisms guarantee that point.
Sure. Thank you.
Yeah, thank you.
Okay. Shafu, I guess you were next, then Ishu. Shafu, you seem to be on mute again. Okay. Ishu, you want to go ahead while Shafu has a discussion with his audio?
Pleasure. So I have actually a clarification question. Can you please go to page 5, I guess?
Yeah,
Yeah. So if I understand correctly, it looks like this small picture. You have the blue packet.
yeah,
Uh, so it looks like there is a difference from the cycle idea. Or the TCQF is here. You want to in real time adjust that the blue packet, when the blue packet arrives in node B, it could be possibly either put into cycle 2 or cycle 3. This is this is a real-time determination, depending on
no,
whether the
it's
cycle 2 is already full or is
no,
predetermined
no.
by the controller.
Yeah, it's predetermined by the controller. The flexibility is not real time. It's just the flexibility by the controller when the path calculation is happening. When the controller will see whether the results of cycle 3 is enough. If it's not, it can put it in maybe a cycle later. That is determined by the controller beforehand. It's not happening real time.
Oh, okay. So that means once the controller determines this mapping, then all the packets following this cycle
Yes,
mapping relationship. If I want to
yeah,
change it, I need to go through the whole life cycle again. So at a
yes.
certain time point, then I do it all at once. It's not a real time put here and put there determined by. Okay, I see.
You are right. You are right. It's not real time.
Okay, so one more small question.
Mhm.
Why at the node B there are two blue packets?
Oh,
So
it's
there are
sorry.
two and
It's kind of confusing. The first one is means that it arrives, and the second one it means it is sent out. It's the same packet actually. It's just in different time. Uh, uh,
arriving time and transmission, receive and transmission time.
yeah,
Okay,
it means that it is received in cycle 2 and sent out in cycle 3. There is only
so
packet
oh okay,
all
so
on the path.
basically, okay, so if that the case, so basically the more likely the controller should determine that the transmission time or transmission cycle for example for node B is from cycle 1 to 3 and at node C is from 3 to 5, something like that.
Yes,
I-
yes. Actually,
okay,
it
okay,
is
I,
decided.
okay, I see, thanks.
Yeah. Thank you.
Okay. Xiangdong?
Can you hear me okay?
Yes, we can.
Okay. Okay, thank you. Uh, so if I understand correctly, cycle of each node doesn't have to be synchronized with the cycles of other nodes, right?
Yes, but the frequency has to be synchronized.
Yeah, frequency has to be synchronized. Then how about the controller? I mean, uh, does controller need to know when the cycle of each node starts?
Yes, the controller has to know it
Uh,
exactly because it has to
okay.
schedule.
So we need some time synchronization between controller and each and every node,
Yes,
right?
you're right. Yes,
Okay. So controller needs to maintain kind of a separate synchronization with each node to make sure what time instance the cycle of each node starts. Is that correct?
yes, yes, that is
Okay.
correct.
Okay. Okay. Thank you very much. Okay.
Thank you.
That's it. Yeah. Okay. Thank you.
Hang on, taking notes. Okay. Taisik?
Can you hear me?
Yes.
Thank you. Can you explain how to calculate the cycle duration when there are multiple flows having different traffic specifications? Can you explain that, please?
Uh, here is a picture, but I don't know whether it can show it very obviously. This is just for one flow. For example, you have a flow and you know the arriving time of that flow, and you just end all the information of delay you have collected, including the link delay, the processing delay, and then you know what cycle the packet should be sent out, right? And then you have another flow. You do the same. Is that your question?
My question is how to calculate the cycle duration, cycle interval. In the
Cycle
slide,
interval?
yes.
You mean the cycle length for each node?
In the slide 5.
In slide 5. Okay.
Yes. In the bottom of the slide that shows queuing latency 10 microsecond. Is it 10 microsecond or 10 millisecond?
Queuing delay here, right?
Queuing latency.
Oh.
Yes, right.
Oh, sorry. It's
I think it's a microsecond, right?
Yeah, microsecond.
Then my question is how to decide or calculate the 10 microsecond of queuing latency when there are multiple flows having different traffic specifications.
Oh, okay. I understand your point. You mean how to calculate the queuing latency? It is determined by this one, the queuing mechanisms, because we have 3 queues, and when the packet arrives, it has to, because there is one output queue. It means that this queue is only make the packet out of the queue and don't receive queue at this cycle. And we have two more queues. That means that these 2 queues only put the packet inside, and it won't send out the packet at this cycle. So when we have a packet arrives, it will be in Q2 or Q3, and in each queue, it will the output queue length. That means that the length of the queuing sending out packet is 10 microsecond, and because there are only 3 queues, and the longest time the packet will stay inside the queue is 2 cycles. So the queuing length is 10 microseconds. That is the longest time it will be inside the queue, but it can be shorter. The jitter will be tolerant in that in these 3 queue cyclic mechanisms. And I noticed that you also mentioned that how it can be guaranteed when there are multiple flows. That is also the point how to do the resource reservation, because the cycle capability equals the link capability, and multiple the cycle duration. So if the cycle capability is full, there will be no more queues and ended to that cycle. So that guarantees that all when the packet is put inside the queue, and when the queue is becoming the output queue, all the packets inside the queue can be sent out in that cycle. It is guaranteed by this.
Yeah. My question was is the cycle duration related to the flow specifications? If, for example, packet interval of some flow. So my question is,
yeah, I understand. It's not related. The cycle is planned by each node beforehand, and then when the traffic arrives, the traffic specification will be different from the cycle. For example, in this, I just make it easy to understand to in each cycle there will be one packet. But based on the traffic specification, it can be quite different. For example, 10 cycles, one packet. It just depends on the traffic specification, not related to the cycle planning.
So the cycle duration can be arbitrarily determined or decided by somehow,
Yes.
right?
Yes, yes. It can be planned by the requirement of the network, for example.
Okay, anything else?
Okay.
Okay. Shisong, please send me these slides, but before you do that, please remove the Huawei confidential footer.
Oh,
And if the
sorry.
Chinese also says Huawei confidential, that should also be removed, please.
Yes, yes. I sorry. I just
No,
used.
I understand
the-
this. I've had email with my stupid Dell internal confidential labels go to IETF list, and I have to go fix it. So I understand. Just please send me the slides without that footer, and I will get them posted for you.
Yeah, yeah. Okay. All these contents are public, so I will remove
I
this.
assume as much. The other thing is, I saw what might have been patent application IDs here. If those are important to the draft, you might need to ensure that a suitable IPR notice is filed with IETF.
Sorry. The second question is.
On one of your slides, I saw some large numbers that looked like they might be patent application numbers.
Oh, yes, I understand. You mean, I think you mean
Yes,
this one,
bingo.
right? Yeah. Yeah. Okay.
The one you
I will.
just had up a moment ago.
Yeah.
I think
Okay.
it was
I will
slide
look
50.
into it.
Yeah, please look into it. If those are important to what you're proposing, you'll need to you should arrange that they be disclosed to the IETF.
Yes. Okay. Okay. I will check it.
Thank you.
Okay.
Let's see, those patent number that was on which slide? 18, I think it was.
16.
No, it was either 15 or 18. No, maybe 14.
14. This one?
No, okay. There was one of those slides, so it must be 18 then. I'm getting lost. I can't remember which slide. One of these slides contain patent numbers. One more, try 18. There they are. It's on patent. Okay, slide 18. Okay.
Okay.
All right.
Oh, you mean this one?
Yes. If that's a patent, if that's a patent application, you should arrange to file an IPR disclosure with IETF.
Okay. Okay. I will do that.
Sorry, but that.
It's okay. Actually, this is for the load balancing. It's not for the mechanisms itself. But I will check. The load balancing.
Check. I suspect your lawyers have a very good idea about whether this is necessary and how to do it.
Yeah. Okay. Okay, maybe I will stop sharing.
I think so. Thank you very much. You've certainly raised enough questions to consume plenty of time.
Thank you.
Okay. Anybody else have anything they want to talk about, or? Xiaofu, did you get your audio unmuted?
Oh, Thank you. I have no more words to say.
Okay.
Just say thank you. Bye bye.
All right. Okay. I think we might be done. Any other questions or comments? All right, I think we're done. I'm not quite sure how to turn the meeting off. I think it will turn itself off at the top of the hour. Jiangdong? Anybody?
Oh no, I was just saying goodbye.
Okay. Thank you very much, everybody. Goodbye.
Thank you, everyone. Bye bye.
Bye bye. 이거 뭐